Hello everyone, this is a problem involving a potential energy function. Uh, it is given that a particle can move along x-axis under influence of a conservative force. It is clearly given that the force is conservative. The potential energy of the particle is given by U equal to 5x square minus 20x plus 2 joule, where x is the coordinate of the particle expressed in meter. It is given that the particle is released at x equal to minus 3 meter. So we have to find the maximum kinetic energy and the maximum x coordinate of the particle during the subsequent motion. So if we carefully plot this given function, this potential energy function, U equal to 5x square minus 20x plus 2, it is a upward parabola and it will look like this. So this is the variation of U with x, and there will be a minimum observed somewhere at x equal to 2. It is already given in the plot. We will actually calculate that. So the potential energy is minimum when we know that du by dx should be 0, when the potential energy is minimum. And if we differentiate the given expression of U, we get 10x minus 20 equal to 0, which on solving gives us x equal to 2 meters. And as we can see that at x equal to 2, the value of U comes out to be minus 18 joule. Also, since the particle was released at x equal to minus 3 meters, this instant, so at x equal to minus 3 meter, the value of U comes out to be 5 into minus 3 whole square minus 20 into minus 3 plus 2, which comes out to be 107 joule. In fact, since the particle is released at x equal to minus 3, the kinetic energy will be 0 at that instant. So we can argue that the total energy of the particle is in fact 107 joule only. So we can say that since the kinetic energy is 0 initially and the potential energy at that instant is 107 joule, so the total energy is 107 joule only, and this total energy will remain conserved as it is a conservative force. So at x equal to plus 2, when the potential energy is minimum, the kinetic energy at this instant must be maximum, and this maximum kinetic energy can be found simply by subtracting the potential energy, the minimum potential energy at that instant, from the total energy. So 107 minus minus 18. So this gives us 125 joule. So this is the maximum kinetic energy. And this occurs at x equal to 2 meters, when the potential energy is minimum. So we have solved the first part of the problem. In the second part, we have been asked the maximum x coordinate of the particle that it will travel. So again we can see from the symmetry of the graph that somewhere here the potential energy will be maximum and kinetic energy will be 0 at that instant. So since it is a symmetrical graph, we do not need to again go into too much of calculations. This interval you can see is 5 meter between x equal to minus 3 and x equal to plus 2. So if you add another 5 meter to x equal to 2, you will get the x coordinate easily. So x equal to 7 meters will be the final coordinate, in fact the maximum x coordinate that the particle will travel. So that is it. I hope you get this problem. This is a very nice problem from Work Power Energy. Thank you very much.